Hi everyone, this is a video going through some chemical calculations and we're particularly looking at some titration calculations with this one. So let's have a look. This question is saying that a student titrated 25 centimeter cube portions of sulfuric acid with sodium hydroxide of this particular concentration. And you can see they've done the titration 5 times. They've got various different results every time. They've given us the equation and they want us to calculate the concentration of the sulfuric acid. Okay, this is the most common thing that you use a titration for, is to work out the concentration of chemical that you don't know the concentration of. So it says use only the concordant results. Okay, we do need to know what that means, but it's nice here, they've actually told us. Concordant results are those within 0.1 centimeters cubed of each other. So the first thing is, let's find these. So if we're looking here, we've got 23.5, 21. So we're just going to look at these three. Right, these are the concordant results that are within 0.1 of each other. So we're going to ignore these two. So the first thing we're going to do then is work out the mean of these concordant results. Okay, so we're going to add them up and divide by 3. Divide that all by 3. That's going to give us our mean titer. So 22.1 plus 22.15 plus 22.15, divide that by 3, and we get 22.13 recurring centimeters cubed. Okay, so what we want to do now is we want to use this to calculate the number of moles. Okay, but to do that, we're going to use the concentration in moles per decimeter cubed, but this volume is in centimeters cubed. So we need to convert that into decimeters cubed first. So to do that, we're going to divide it by 1,000. I'm not actually going to calculate it. I'm just going to write 22.13 divided by 1,000, and that will now be in decimeters cubed. Okay. And then what I want to do is, then if you look at moles per, that's moles per decimeter cubed, right? So if I then multiply that by decimeters cubed, it's going to give me moles. Okay. So we're going to multiply this by the concentration. So this was the volume of the sodium hydroxide that we used. So we need the concentration of the sodium hydroxide, which is this value they've given us up here. Look, that was the concentration of the sodium hydroxide. So we're going to multiply by this. So we're going to times it by 0.105 moles per decimeter cubed. Okay, and let's work that out. So I've got this value. I'm just going to divide that by 1,000, and I'm going to times by 0.105. And I get, this horrible looking number, 2.324 times 10 to the power of minus 3 moles of, that's the sodium hydroxide, wasn't it? Yeah, we used the sodium hydroxide, so that's the NaOH. Okay, so we've worked out the number of moles of the sodium hydroxide. Now what we need to do is use this equation and look at the ratio, okay, because we want to work out the concentration of sulfuric acid. At the moment, we've only got information about sodium hydroxide. So if we look at our equation, we can see that what's the ratio of sodium hydroxide to sulfuric acid? Well, in my equation, I've got 2 NaOH, but I've only got 1 H2SO4. So if this is the number of moles of sodium hydroxide that I've got, it's telling me I'm going to have half as many moles of the sulfuric acid. So I'm going to take this number and I'm going to divide it by 2. I'm going to divide that by 2. And we get 1.162 times 10 to the minus 3 moles of the H2SO4. Okay, now finally you can see that we want to calculate the concentration in moles per decimeter cubed. So for this, you don't need to remember the triangle involving concentration. I mean, it's helpful if you can, but actually, look at the units. It shows you what you've got to do. You've got to do moles divided by decimeters cubed. Well, there's the moles. So what's the decimeters cubed? That's the volume, isn't it? So we need to know the volume of the sulfuric acid. So we need to go and find that in the question. It's right up the top here. We had 25 centimeters cubed of sulfuric acid. Okay. But we need to get that into decimeters cubed, don't we? So we need to divide it by 1,000. Okay. So what we're going to do is this number of moles, 1.162 times 10 to the minus 3 moles and we're going to divide that by the 25 centimeters cubed, but we need to do 25 divided by 1,000 to get it into decimeters cubed. Okay, so I'm going to do that value divided by, and then in brackets, 25 divided by 1,000. Does that make sense? So I want to get that into decimeters cubed first, so that's what I'm doing here, and then I'm going to do my answer that I had, the number of moles divided by that. Okay. And that's going to give us our answer. So we end up with, does it say anything about a number of decimal places? Nope, doesn't mention it in the question, so they can't mark us down for that. So I'm going to say 0.046 moles per decimeter cubed. Does that seem reasonable? Let's just do a check. You should find that when you're doing a titration, that the concentrations of the acid and the alkali, are similar to each other, right? They won't be exactly the same, but they should be somewhere near, right? You don't want one to be 0.5 and the other to be 7,000, right? That suggests you've done something a bit dodgy, okay? So we've got 0.046, and the concentration of the other one was 0.1. So that seems reasonable, right? They're somewhere near each other. Okay, so that gives us a clue. We're in the right ballpark. We've probably got this right. Okay, let's do one more. Okay, you can see, look, the other thing I want to show you is look at this question compared to this one. Right, it looks exactly the same, look. They've even got 5 things in a titration, in a table. Okay, it's very, very similar. That's a 5-mark question. This is a 5-mark question. Okay, so if you practice these, you can get used to them. Okay, because the question is almost the same every time. They just give you different numbers to use. So let's have a look here. Students titrated citric acid with sodium hydroxide. We had 25 centimeters cubed of sodium hydroxide. That's the same as the other one. And a few drops of indicator. This indicator is called thymol blue. Okay, if you say so. Doesn't really matter. It's blue in alkali, it's yellow in acid. Okay. Add the citric acid from the burette until the end point is reached. So that would be when there's a colour change. So here's the results. We've got 5 of them again. Here's the equation. Here's the concentration. Look, this is how similar it is. Look, I just want to show you these questions. Look, we've got 25 centimeters cubed. 25 centimeters cubed. Concentration was 0.105. Here, the concentration is 0.102. Right, this is how lazy they are with the questions, right? If you practice these questions, the same thing comes up, right? So you can be like, I've pretty much done this question before. We've got a different equation here, obviously. This is going to make a difference. Okay, but the questions are very similar. It's really worth practicing these. And again, we've got to calculate the concentration. Use only the concordant results. Again, it's told us concordant results are within 0.1. So we're starting off exactly the same here. So where are the ones that are within 0.1? So it's going to be this one and this one and this one. They're very similar. Okay, and look, even that's the same. It's 12.1, 12.15, 12.15. And this one was 21.1. Oh, sorry, 22.1, 22.15, 22.15, right? Look, it's so similar. Okay. So you really can practice these. Right, let's calculate this then. So we're going to work out the mean again. So we're going to add these 3 up and divide by 3. So 12.1 plus 12.15 plus 12.15 divide by 3. And we get 12.13 recurring centimeters cubed. Right, so that was the volume of the citric acid. Okay, so we want to multiply this by the the concentration of citric acid is the one we're supposed to be working out. Just put a box around that to remind ourselves what we're doing. Okay, so we can't do anything with that number yet, because that's related to this, which we're trying to work out. So we must be able to do the sodium hydroxide. We've got the concentration of the sodium hydroxide. So where's the volume? That must be here somewhere. Yeah, 25 centimeters cubed. Here we go. So we're going to use this number and this number. So can you see? Because these are both sodium hydroxide, sodium hydroxide. So that's where we're going to start. So we're going to take that 25 centimeters cubed, and we need to divide that by 1,000 to get it into decimeters cubed. And then we're going to multiply that by the concentration. Again, can you see this is moles per decimeter cubed? So we need to multiply by decimeters cubed, and that will leave us with moles. Okay. So we're going to times that by 0.102 moles per decimeter cubed. Okay. Right, we'll leave them. I'll come back to that number later on. 25 divided by 1,000 times 0.102. So that is 2.55 times 10 to the minus 3. And that is the number of moles of the sodium hydroxide, wasn't it? So now, the same as we did on the last one, we now want to look at the ratio. So we're going to look at our equation, and we're going to say, it's a sort of scary looking thing here, C4.8, but don't let that worry you. You can see here that there's only one of those, but there's 3 of the sodium hydroxide. So every time I have 1 mole of this, I'm going to have 3 moles of sodium hydroxide. So if this is how many moles of sodium hydroxide I've got, I need to divide by 3 to get to the number of moles of this one. So I'm going to have to do this number divided by 3. Can you see? Because we've got this one. So we've got to divide by 3. So I'm going to run out of space here. 2.55 times 10 to the minus 3 divided by 3 is 8.5 times 10 to the minus 4 moles of the citric acid. What was it? C6H8O7. Right, and now finally we want to do the concentration in moles per decimeter cubed. So again, you can see the units are telling you what to do. Do moles and divide it by decimeters cubed. Well, here's my moles. So I'm going to take that, 8.5 times 10 to the minus 4. I'm going to divide that by the volume. So it was this number that we haven't used yet, but that's in centimeters cubed. So I need to divide that by 1,000. I'm going to do 12.13 over 1,000. And that would get it into decimeters cubed. So what I'm going to do here is I'm going to work this out again. So 12, because this is recurring, so it's an awkward number. 12.1 plus 12.15 plus 12.15 divided by 3. That gives me that number. And I'm going to do 8.5 times 10 to the power of minus 4 divided by, and I'm going to use the answer button because I had that number before. Okay, so I'm going to do that, and that's going to divide it by that. And we end up with this time. What have I done? That's not right, is it? Oh, I forgot to divide it by 1,000. Oops. Let's do that again. Right, can you see, looking at that number, I can't find it again, but that number was clearly wrong, right? It was 0.000000. I'm like, that's definitely wrong. Let me do this again. Let's work this out again. 12.1 plus 12.15 plus 12.15 divided by 3. Get that? I need to divide this by 1,000, don't I? That's where I've gone wrong. So now I've got that number, and now I want to do 8.5 times 10 to the minus 4 divided by this. So put that in a bracket, 8.5 times 10 to the power of minus 4. And now if I divide that by my answer, I should get something more sensible. 0.07. That looks more like it. Okay. I had 0.00007. That was definitely dodgy. And then again, let's just see, is that reasonable? Well, the other calculation, the other concentration was 0.1, so 0.07. Yeah, they're somewhere near each other. Again, if I'd done it before, I had 0 and then 3 extra zeros. So can you see that number is nowhere near 0.1, right? That's much, much smaller. So that's why as soon as this came up, I was like, I've done something wrong here. That can't be right. Okay, so it's worth just thinking about, is it a sensible value? Okay.